Our quest begins with the search for exoplanets. Astronomers utilize powerful telescopes like Kepler and Hubble to detect planets outside our solar system. These instruments have revolutionized our ability to explore the cosmos. Now you might be wondering, what exactly are exoplanets? Well, simply put, they're planets that orbit stars outside our solar system. Imagine our Earth, but in a completely different part of the universe. Fascinating, right? To find these distant worlds, astronomers use a variety of methods. One popular technique is the transit method. When a planet passes in front of its star, it causes a slight dimming of the star's light. By observing these tiny drops in brightness, astronomers can infer the existence, size, and orbit of the planet. It's like a cosmic game of hide and seek. Now let's talk about our trusty space telescopes. The Hubble Space Telescope, launched in 1990, has been instrumental in the hunt for exoplanets. Its high-resolution images and spectra have provided valuable insights into the properties of these distant worlds. But the real game-changer was the Kepler Space Telescope. Launched in 2009, Kepler was specifically designed to find Earth-sized planets orbiting other stars. And it didn't disappoint. Kepler discovered over 2,000 exoplanets during its mission, vastly expanding our knowledge of the universe. These telescopes have not only found exoplanets, but they have also helped us understand the conditions on these worlds. Are they gas giants like Jupiter or rocky worlds like Earth? Is their atmosphere thick or thin? These are crucial questions that help us determine if a planet could potentially sustain life. So we've embarked on our journey, but where should we look for these Earth-like planets? That's where the concept of the Goldilocks Zone comes in. But we'll delve into that in the next scene. So hold on tight as our cosmic voyage continues. Enter the Goldilocks Zone. It's a sweet spot around a star where conditions are just right for liquid water to exist, the key ingredient for life as we know it. This zone is crucial in identifying potentially habitable planets. The Goldilocks Zone, also referred to as the habitable zone, is a band of space around a star where conditions are not too hot, not too cold, but just right for the existence of liquid water on a planet's surface. Picture it as a cosmic comfort zone, a perfect distance from a star where a planet could potentially host life. Why is this zone so important, you may ask? Well, every form of life on Earth, from the smallest microbe to the largest mammal, requires water to survive. It's the universal solvent, the cradle of life, the medium in which all biochemical reactions occur. Thus, finding a planet in the Goldilocks zone of its star is a significant first step in the search for extraterrestrial life. But it's not just about temperature. A planet in the Goldilocks zone also needs a suitable atmosphere to maintain liquid water. If the atmospheric pressure is too low, water will evaporate. Too high, and water will remain in a perpetual state of high-pressure ice. In this delicate balance, the role of a planet's atmosphere is pivotal. Furthermore, the planet's composition plays a role too. For life as we know it to exist, the planet should ideally be rocky, like Earth, rather than gaseous, like Jupiter or Saturn. A rocky planet could have a solid surface where water could pool into oceans, lakes, or rivers, providing a potential habitat for life. However, even if a planet checks all these boxes, it doesn't necessarily mean it's teeming with life. Many other factors come into play, including the planet's age, the stability of its orbit, its magnetic field, and more. But just being in the Goldilocks zone doesn't automatically make a planet an Earth twin, does it? To truly determine a planet's habitability, we must delve deeper into its characteristics and conditions, a challenge that continues to inspire and drive the scientific community forward. Let's talk Earth analogs. While not identical twins, scientists have discovered planets with similar size and conditions. Thanks to the Kepler Space Telescope, we've uncovered a treasure trove of diverse exoplanets, some with intriguing similarities to Earth. Now, what do we mean by Earth analogs? Simply put, these are planets beyond our solar system that share key characteristics with Earth, such as size and surface temperature. These planets are not carbon copies of our home, but their similarities make them fascinating subjects for study and speculation. The Kepler Space Telescope, launched in 2009, has been instrumental in this search. Its primary mission was to find planets in the habitable zone of their stars, where conditions might be suitable for life. And boy, did it deliver! Kepler found thousands of exoplanets, many of which are Earth-sized and in the habitable zone. Let's take Kepler 186f, for example. Discovered in 2014, it's about 10% larger than Earth and orbits its star in the habitable zone. Or Kepler 22b, another exciting find. It's about 2.5 times the size of Earth and also sits comfortably in the habitable zone of its star. These are just two examples among many, each contributing a piece to the puzzle of potential life beyond our planet. But the question remains, are these planets truly habitable? Do they have atmospheres, water, maybe even life? Unfortunately, Kepler can't answer these questions. Its mission is to find and categorize exoplanets, not to analyze them in detail. That's a job for future missions and technologies. With thousands of exoplanets discovered and many more waiting to be found, what does the future hold for our cosmic exploration? We can't say for sure, but one thing is certain. The universe is full of possibilities, and we're just beginning to scratch the surface. Our cosmic exploration doesn't stop there. Future missions like the James Webb Space Telescope promise more detailed observations, offering a glimpse into the atmospheres of these distant worlds and furthering our understanding of their potential habitability. As we journey deeper into the cosmos, we are constantly developing new technologies and strategies to aid in the hunt for Earth-like planets. The next generation of space missions is poised to take us even further, expanding our cosmic horizon and bringing us closer to answering the age-old question, are we alone in the universe? Let's talk about the James Webb Space Telescope for a moment. This marvel of modern technology is set to launch soon, and it's expected to revolutionize our understanding of the universe. With its ability to observe in the infrared spectrum, it will be able to penetrate the dusty veils of distant galaxies and, more importantly, probe the atmospheres of exoplanets. By studying the light that filters through an exoplanet's atmosphere, we can decipher its chemical composition. We can look for signs of water vapor, oxygen, methane, and other gases that might indicate the presence of life. This method, known as spectroscopy, could potentially confirm the existence of a truly Earth-like planet, one that not only resides in the Goldilocks Zone, but also possesses an Earth-like atmosphere. Beyond the James Webb Space Telescope, other exciting missions are on the horizon. There's the Plato mission, aiming to find and study a large number of Earth-sized planets and super-Earths. There's also the TESS mission, focusing on finding planets around the nearest and brightest stars in the sky. Each of these missions holds a piece of the puzzle in our quest to find other Earths. Yet, as we push the boundaries of our knowledge and technology, we must remember that cosmic exploration is a marathon, not a sprint. It requires patience, perseverance, and a healthy dose of curiosity. It's a quest that will likely span generations, but each step we take brings us closer to understanding our place in the universe. While we're making great strides, our journey is far from over. The universe still keeps us guessing. Of course, the universe keeps us on our toes. We face challenges and unanswered questions. Yet, it's the pursuit of these answers that propels our understanding of the cosmos forward. Space exploration is not without its hurdles. One of the greatest challenges in searching for Earth-like planets is the sheer distance. These exoplanets are light years away, making direct observation difficult. Our most powerful telescopes can only provide us with limited information, leading to inferences and theories rather than concrete facts. Another challenge lies in the interpretation of data. With the vast amount of information collected by our space telescopes, it's a daunting task to sift through this cosmic haystack for the needle that is an Earth-like planet. Specialists laboriously analyze this data, looking for the telltale signs of a habitable world. Then there's the question of life. What does life on an exoplanet even look like? Our understanding of life is based on what we know here on Earth. Could there be life forms that exist in conditions we deem inhospitable? This question opens a Pandora's box of possibilities, adding another layer of complexity to our search. Despite these challenges, the intrigue and excitement of space exploration remain undiminished. Each challenge presents an opportunity for innovation, pushing the boundaries of what we know and understand. Each unanswered question serves as a motivator, driving us to delve deeper into the mysteries of the cosmos. The search for Earth-like planets is more than a scientific endeavor. It's a quest that engages our curiosity, our ingenuity, and our ambition. It's a journey that reminds us of our place in the universe, inspiring awe and wonder at the vastness of the cosmos. And there you have it, a whirlwind exploration of the quest for Earth-like planets in just 10 minutes. If you're as fascinated by the cosmos as I am, consider subscribing for more quick dives into the wonders of our universe. Until next time, stay curious and keep looking up.